Hey guys, long time no see. In this video we're going to go over our pre-covering checklist. All the little things that we could think of that we still needed to finish up before we start the covering process. So stick around and we'll show you all the little things we did from front to back. Alright, so starting with the formers. Most of our formers came with a few small pop rivets holding them in place to make it easier for us to figure out where and how they're installed. So the first thing we did was drill these small rivets out. Then we drilled through the remaining former mounting tabs, and then we drilled everything out for 1/8" pop rivets. After everything was deburred, we attached most of the formers with stainless steel pop rivets. We're putting headset jacks and USB charging ports in for the back seats. I decided to make little brackets that mount in the aft corner of the front doors to hold these plugs. I cut the brackets out of scrap 032 aluminum and then bent the tabs where they'll attach to the former mounting tabs. Then we marked and cut out for both plugs and installed nut plates for the USB ports. The last thing I did to the brackets was add a stiffener to the one side that's not supported. One other thing I added in this area was a small angle piece to stiffen up the door sill formers. With the brackets in place, I installed the USB charging ports and the headset jacks. We decided to install the 6-pin LEMO headset jacks, and the ones we purchased didn't come with wires long enough to make it from the back seats to the panel, so we had to splice in more wire. The common mic conductors are shielded. Splicing shielded wire must either be common knowledge or something most people avoid, because I found it a little difficult to find good information on how to do it. I ended up following an example a friend showed me, which used STS solder sleeves. The method he recommended I use went like this. First, we stripped the outside insulation and cut the shield flush. Then we exposed a small amount of the shield. Afterwards, we slid on the solder sleeve to the point where the solder ring inside the sleeve is over the exposed shield. Once lined up, we heated the sleeve with a heat gun. First, the shrink wrap tightens up. Then if you keep heating, the solder ring melts into the shield, soldering it to the lead. On the other end, we slid over a sleeve with the lead pulled out. At this point, we connected the two internal conductor wires with butt connectors. Afterwards, we slid the second sleeve into place. Cut the lead from the first sleeve to length, inserted the lead into the open sleeve, and heated it to connect the shields and finish up the splice. The skylight formers will be somewhat visible, so after removing them, we painted them with a little spray paint out of a can. I'm sure most of you are shaking your head at the thought of someone painting any piece of a six-figure project with a rattle can, but it's a ranch plane. Moving back is the rear windows on the left side. The first thing we did was fabricate a piece that will connect the two rear window frames and still allow for replacing either window. Using a scrap piece of 032 aluminum, we bent a lip in the front side to make it a little more rigid. Next, we needed to add a fairly thick joggle. To accomplish this, I taped the piece into a jig I made from some scrap wood and then hammered in the joggle. With a successful joggle, I clamped it in place and match drilled holes to fasten it to the forward window. Next, I marked where to trim the forward window frame and where the reinforcing stringers will penetrate the door former. To keep the window frame from protruding out any more than necessary, I cut the back piece off to be in line with the aft end of the former, so the inside of the back piece will sit flush with the outside of the former once it's installed. On the back side of the front frame, we're mounting some leftover stringer material to keep fabric from deforming the window frame when it's shrunk. So we notched out a piece in the formers to allow the stringer material to pass through it. Once I had everything held together with Clecos, I put it all in place and then used strips of tape to help visualize how the fabric will lay with the window. Once I was happy with how it looked, I drilled the holes that would attach the frames to the fuselage. The forward window frame attached with a standoff in the middle at the top and at the aft end of the bottom of the frame. And then a hole at the top and bottom of the frame that attached it to the door formers. These two holes go through the window frame, the door former, and join the stringer material on the back side. We attached the small D frame to two standoffs in the front and to one of the stringers. After everything was deburred, I started putting the pieces together. I used flush rivets where the bridge piece attaches to the forward window and pop rivets everywhere else. Dakota didn't find all this riveting quite as riveting as I did. Next up are the static ports. First, we made little brackets to fasten the static ports to the stringers. We put a 90-degree bend in the brackets and drilled holes for the rivets that will hold the bracket to the stringers and the hole the static port will pass through. Next, we drilled holes in the flange around the static port for riveting it to the bracket. Afterwards, we match drilled the holes to the bracket and fastened them with flush head rivets. It sounds like lots of Bearhawk builders have put their static ports on either side of the fuselage in the bay behind the cargo bulkhead and have had good results. So that's where we've put them as well. Before drilling them to the formers, we made sure the static port flange would sit flush with the back side of the fabric and the nipple would pass through. Once the bracket was riveted in place, I installed a 90-degree elbow in both ports that points straight up to help keep water from entering the system. On the stringer above one of the ports, I installed a bracket that supports a T where the two ports will join. On the stringer above the other one, I installed a piece of aluminum with a hole drilled to accept a snap bushing. Then I connected everything with the airline. The connectors I used are the quick connect style, so I was careful to cut the airlines square and clean. After cut to length, the lines slide into the connectors and are held tight against an O-ring. The lines can't pull back out unless the release ring is pushed. The last item on the list is the ELT. First, we needed a tray or a plate to mount the ELT and the antenna to. To accomplish this, I doubled up some 032 aluminum. I cut this out of scrap and added a 90-degree to the edges that weren't supported for a little more strength before riveting the pieces together. Next, we drilled the plate to the mounting tabs on the fuselage in the bay behind the cargo bulkhead. We also drilled a hole to fix the antenna directly to the plate and riveted the plate to the tabs. This is a monopole antenna that needs a good ground plane for it to work properly. We're counting on the fuselage tubing to act as the ground plane once fastened together, but it's something we'll need to test to confirm. Then I mounted the tray that came with the ELT to the plate we fabricated with screws and nut plates. Once installed, I tried wiggling the ELT or flexing the tray, but it all felt pretty solid, so I'm happy. To finish up, we connected the antenna and the ELT with the cable that came with the ELT. That pretty well covers everything we had on our list to take care of before we started the covering process. I'm sure we forgot a few things, and maybe one of you kind folks will point those out to us before we get too far down that path. We spent a lot of time this summer messing around and running all over the place, but the good news is the weather is going downhill here in Nebraska, so hopefully we can start dedicating more of our free time to the Bearhawk. So we'll see you guys in the next one.